Okay, so this screencast is an overview of how to determine and the definitions of empirical and molecular formulas. So first, the definition. Empirical formulas are defined as the lowest whole number ratio of elements in a compound. And an example of that could be a hydrocarbon, where we have this empirical formula. Notice that this formula is just the lowest whole number ratio, so that tells us one carbon for every 2 hydrogen for every 1 oxygen. That can't be reduced to any other ratio and still maintain a whole number. And we need whole numbers when we're dealing with actual atoms, because we can't have halves of atoms. Molecular formulas actually represent reality. So it's going to be some multiple of the empirical formula that tells us the actual number of elements within a single molecule of the compound. So if we go back with our previous example, the empirical formula was CH2O, where in reality we might see that same 1 to 2 to 1 ratio in glucose, C6H12O6. Notice that the commonality here is the ratio. They simplify to a 1 to 2 to 1 ratio. So in both cases, the empirical formula is the same, but the molecular formula represents the compound as it exists in nature. And the empirical formula just represents the lowest whole number ratio. So let's talk about how we can actually calculate these things. Generally, we need to just know a couple of things to be able to determine the empirical formula. For the empirical formula, we need to determine the number of moles. So if you think about that, this is the key piece here, because that mole ratio gives us the actual formula. So we need to determine the number of moles. And then from that we take the mole ratio, and then if necessary we're going to multiply so that we get a whole number ratio if you happen to get any halves or other fractions. And so let's look at this through the context of an actual problem. So the problem reads, determine the empirical formula of a compound that's 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen. Well, the first thing is, let's assume we've got a nice round number of sample to work with. And typically 100 grams makes a lot of sense because the percent compositions always add to 100. So we're going to assume we have 100 grams of it. So in 100 grams, we would have 71.65 grams of chlorine. And remember that first step. We need to figure out the number of moles. So we look up the molar mass for chlorine, 35.45 grams is 1 mole of chlorine. And from there we can figure out the number of moles that we're dealing with, which you do the math and you get it 2.02 moles of chlorine. Now we repeat this process for every single element involved. So we'll do carbon next. 24.27 grams of carbon. The molar mass of carbon, 12.01 grams, 1 mole. And we get an answer of 2.02 moles of carbon. And then finally hydrogen. So we have 4.07 grams of hydrogen, converting it to moles, 1.0079 grams for every mole of hydrogen, and we get around 4.04 moles of hydrogen. From here we're going to go back to our final step. And our final step is to just take the ratio of these 3 elements. And it's easiest if you just do them starting with the largest on top. So if you notice, the largest number of moles is hydrogen. So I'm going to take a ratio of hydrogen to carbon first. So that is 4.04 to 2.02. And notice that gives me a 2 to 1 ratio. So that means 2 hydrogens for every 1 carbon. The next piece, I do a similar ratio with hydrogen and chlorine. So I'm going to do a hydrogen to chlorine ratio. 4.04, 2.02, and I get 2 hydrogens for every 1 chlorine. From there, I can write the empirical formula. Alright, so once we have all of our ratios, we can write our formula. And so our formula has to maintain these two ratios, the 2 hydrogen for 1 carbon and 2 hydrogen for every chlorine. So putting that all together, we can write it here in black as CH2Cl. And that's what would be our empirical formula, keeping that 1 to 2 to 1 ratio in force. Let's look at another example that you can actually try. So let's say that we're given an additional piece of information about this compound. The compound that we've previously figured out has an empirical formula of CH2Cl. Let's say that now it asks us to determine the molecular formula. And notice it gives us some additional piece of information. It gives us a molar mass in terms of grams per mole. Well, that's important because now we have enough information to be able to see if this empirical formula matches up to the molecular formula. So to do that, we need to calculate two things: the empirical formula mass and then the molecular formula mass, which in this case is given. The ratio of those two things, so the molecular formula mass over the empirical formula mass, will give us some number that we will then multiply by our empirical formula to get our molecular formula. Let me show you what I mean. First, let's start by calculating the empirical formula mass of CH2Cl. And by now you should feel comfortable doing that. So the empirical formula mass of CH2Cl would be, count carbon once, so 12.011, plus, oh, that plus sign looks horrible, plus 2 times the mass of hydrogen, plus 1 chlorine. And that gives us an empirical formula mass of 49.48 grams per mole. So now you'll notice that the next piece is we're going to compare the empirical formula mass, which is here boxed in black, to the molecular formula mass, which you'll notice is boxed in red. So we take the comparison of those two things, empirical formula mass, or molecular formula mass on top, so it's 98.96 over the empirical formula mass of 49.48, and we get an answer of 2. And really that means 2 to 1. What that tells us is the molecular formula of this compound is 2 times the empirical formula. So if our empirical formula is CH2Cl, our molecular formula must be 2 times that. And I'm going to write it here in red. So it must be C2H4Cl2. Notice the thing that's always true. The ratio is still the same as in the empirical formula. It's just we must have this particular number of atoms combining in order to give us the molar mass that's stated in the problem of 98.96 grams per mole. Now I want you to try an example on your own, and feel free to pause this video as you go, stopping it or rewinding it as needed to solve the problem. So here's the problem. So we take a white powder and it contains phosphorus and oxygen. The percentages are given as well as the molar mass. So I want you to determine the empirical and the molecular formula for the compound. This is a good point to pause the video. Work the problem out before you move on. If you did the problem correctly, the empirical formula that you should have calculated should have been P2O5. P2O5. And based upon the molar mass comparison, the molecular formula that you should have calculated was 2 times that. So that would be P4O10. Hope this was helpful. Have a good evening.